So I'll give you a very quick demo about how SAM works as well. So SAM is made up, as I mentioned, about these hardware blocks, and they're represented within our program here. So I'm just going to grab these and move them to the side. So in my hands, I've got a button and a light. They're paired already, and that means that they've showed up on my screen there. So you can see my button and my light here. Now, if I want to start programming, I can grab my button here, and I can drag it onto my canvas like so. And as I do that, it changes color from white to blue. If I grab my LED as well, that changes to a different color. So at the moment, this one is part of the blue circuit, and this is part of the green circuit. They're not yet connected. Now, if I want this button to control the light, I don't need to connect them together, don't need to wire them up, don't need to solder anything. All I need to do is simply, see if I can do this, connect the dots between them. Now they both turn blue, and when I press the button, the light turns on. And that's how easy it is to start programming. And I can take this very simple concept, and I can start doing some very cool things with it. So say I want the color of the light to change. I don't want just a white light, I want maybe a red light. I can go in, see if I can double click. I might need to do it on here. There we go. And I can choose any color I want. So as I move that around, it's now going to be programming to that new color. It's being a little bit slow today this morning, but basically if I press OK, in a few seconds this will be reprogrammed to be a blue light. But it's not just about connecting one piece of hardware to another piece of hardware. It's also about changing how they talk to each other. And this is where the software blocks become incredibly important. So I can say that every time I press the button, I want the color of the light to change by itself. So I can go down here on my menu to my RGB LED section, and I can choose cycle colors. And all I need to do with this is drop it in between. And now, when I press the button, the light is going to change colors from red, green, and blue and cycle through. And maybe I want that to be done by itself. So I can go through and find some other software blocks that help me automate that process. So if I go to my timing controls, I can choose the interval, drop it in between, and I can choose a toggle here to keep the system on. And again, then if I go in, I can change the frequency of that flash simply by writing in a different number here. And the program that I've written is basically going to take a signal from my button to the toggle which keeps something on or keeps it off. That's going to switch over. The interval changes that signal from a constant signal to a flashing signal. That goes through the RGB, and we're going to have a little disco light. So if I press the button once, my light now flashes by itself. So you see, within a few minutes, and with just by dragging and dropping a few icons, we're actually writing a program that controls the different hardware blocks. And this is really the whole concept behind SAM, is real simple interactivity. And for students that might not easily be able to understand code itself or even block-based programming, this is a great approach because it's so visual and so intuitive, you can see exactly what you're trying to create. And then, of course, you can go further. So I can take the same two blocks that I have here in front of me, and I can write a bit more of a complex project. So this is a traffic light, where, actually, I'll remove my space bar, and I'll grab my button instead. And you can see I can so easily remix the project and rewrite something. And I don't need to go in and debug every time. All I have to do is redraw what I want. And now when I press the button once, this is going to be a slightly different project with some if statements. So this is counting how many signals it's received, and that then sends it through. And you see, depending on the number that it's showing, it's going to give me a different color light on the traffic lights. So just with the same two pieces of hardware and a few more software blocks and a new logic applied, I can actually change how they're communicating. So you can keep on building on that up to the point where you can actually go in and you can include things like, where are they? Here, Boolean logic, so like if this and this, then something else, which is a fundamental concept in computer science. And again, you can do that in a very visual way, all the way up to the point of writing custom code as well. So this is JavaScript here. So while it starts with a very easy connection just between a button and a light, it goes up to the point where students can write APIs, they can collect data from online, and they can build much more advanced projects as well. They can essentially sketch out the project they want, and then they can recreate that and write that in JavaScript as well. So you really have a very nice progression from 5-, 6-year-olds being able to use very simple interactions to familiarize themselves with technology and understand the basics, through to university students 3D printing projects, putting SAMs into them, and then writing the project within JavaScript. So you have this really nice progression of SAM.